focus on comparing three ratios. Before that, we are using only two ratios. For example, I can compare the length of this pink pony to the length of this blue pony. I can compare these two together by using ruler. I can actually measure it, which is 35 cm of this pink pony length, and the blue one is about 15 cm. Next, when I come to this, I can also compare this blue pony and the little pony. And if I use a ruler here, I can measure that this is about 15 cm and this is about 10 cm. Then I'll put this down, which is 15 to 10 cm. But my purpose today is not to only compare these two or these two, but I want to compare these three together. How? First, I need to find, oh, this is the first ratio and this is the second ratio. Blue pony exists in the first ratio and also exists in the second ratio, which you can see from here. There is a blue pony here, blue pony here. Therefore, I put blue pony in the middle of the ratio. Then I can plug in pink pony here, because pink to blue, and then blue to little, I can put it down here. Find the same thing from the ratio 1 and ratio 2 and put it in the middle. Next, check for this ratio. For this blue pony, here is 15, blue pony here is 15. So we can, because these two numbers are the same, so we can put it here, 15 cm. 15 to 15, there's no much change. So we can put 35 cm here. 15 to 15, there's no much change as well. So this is 10, I can put the same 10 here. So we can see that the ratio of height of pink pony to blue pony to little pony here is 35 cm to 15 cm to 10 cm. If you look at from the ratio, then we can further reduce it. 我们还可以再约减. So we can actually find a common one. What is common here? What is the same thing? Oh, there's cm here, cm here, cm here. We can slash it off. Next, we can also divide it with the whole number together for this 3. So, can 2 divide by 2? No, you can get a decimal. 3? No. How about divide by 5? Yes, if I divide by 5, for this, this and this all together, I'll get a whole number, 整数. So 35 divided by 5, you get 7. 3, 10 divided by 5, you can get 2. So I can say that the ratio of the height of pink pony to blue pony to blue little pony, pink to blue to little, is 7 to 3 to 2. So this is how we get comparing three ratio all together from two ratios. Here is the ratio of the height of pink pony to blue pony to little pony, which is 7 to 3 to 2. What can the ratio really tell us? Understand from this, the largest number, the lowest number, and there's a number in between, which is lesser than 7 and larger than 2. So from here, we can know that 7, which is a pink pony, is the tallest among these three pony, right? And when we take the least number, the smallest number, we can know that this little pony is the smallest among these three pony. And the blue pony has 3 in between 7 and 2. So we can say that blue pony is smaller than pink pony. 3 is lesser than 7. We also can say that blue pony is bigger than the little pony because blue pony is taller than the little pony. So although this ratio is very simple, 7 to 3 to 2, but it has a comparison which you can understand from this ratio. Hi, welcome back to comparing three ratios. In this library, we have three books. What kind of three books? Storybooks, reference books, same. Magazine, storybook, reference book, and also magazine. I'm going to make a comparison between these three books. Let's have a look at the ratio first. What kind of ratio I have? First ratio, I have storybooks to number of reference books is 2 to 5. This is the first ratio. And then, somebody compared the ratio of reference books to magazine. The ratio is 3 to 2. So we know that we have to find the common thing in ratio 1 and ratio 2. So reference books is here in ratio 1. Reference books is also here in ratio 2. So reference books we can put in the middle. So on the left, I'm going to compare reference books with storybooks. Okay. Also, reference books to the magazine. There are three types here, so three things in my ratio. Okay, you can put one number of magazine, number of reference books, number of storybooks. Next, let's check the reference books. There's ratio of 5 and 3. Are they the same? No, they are not the same. What can I do? To make it in the same ratio, I have to make the reference book as the same. So how? Should I take 5 or should I take 3? Now we can use LCM that we learned before. So we find the common lowest multiple here. For 5 and 3, I look for my lowest common multiple. 5, 5. Okay. So my lowest common multiple is 3 times 5. 3 times 5, which is 15. 15, I'll use this 15 as my common reference books here. Put down my ratio, 15. So let's look at my reference books here. How can 5 becomes 15 here? 5 becomes 15, it becomes larger, so I can use a times here. 5 times what number becomes 15? 5, 1, 5, 5, 2, 10, 5, 3, 15. So 5 times 3 becomes 15. On my right hand side, I times 3. On my left hand side, I need to times 3 as well. So 2 times 3 becomes 6. 5 times 3 becomes 15. Next, let's look at the second ratio. How can 3 become 15? 3 becomes 15, it becomes larger. So I need to times. Times what number? 3, 1, 3, 3, 2, 6, 3, 3, 9, 3, 4, 12, 3, 5, 15. So on the left, I times with 5. On the right, I times with 5. So 3, 5, 15, 2 times 5, I get 10. I can put my 10 here. You might ask, teacher, why do I need to times 3 and not times 5 here? Refer back to this ratio. Ratio says 5 times 3 becomes 15. Right and left needs to times the same whole number. Times 3, therefore, on the left we times 3, becomes 6 here. For this ratio, this is the second ratio, 3 times 5 becomes 15. So here, on the left times 5, on the right, need to times 5, becomes 10. So here, I can put this number together on the same ratio, which is 6 to 15 to 10 represents the ratio of number of storybooks to number of reference book to number of magazine. If you want to bring it up one more level, I can simplify this. Let's see, is there any unit? No. Is the number can be further reduced? 我还可以再约减吗? Check. Divide by 2? Yes, yes. No. Divide by 3? Divide by 3 here, 3 here, 3 here. Can? 10 divided by 3 will become decimal. No, so no. So I think that is the simplest form, 6 to 15 to 10. Let's understand from this I'm referring back to library. So in the library, what kind of books I have the most? 6, 15, 10. Out of these three numbers, 15 is the largest number. So we can know that the number of reference books in the library is the most. 有最多的参考书在这个图书馆里面。What kind of books in the library has the least? 最少的是哪一种呢？ 6, 15, 10. 6 is the lowest number. So I can say that number of storybooks in the library is the least. How about magazine? So I can say number of magazine is lesser compared to reference book, but number of magazine is more compared to storybooks. So we can understand how many books we roughly have in the library and what types of books are there, how many types of books are there, which kind of books has the largest number, which kind of books has the lowest number, which kind of books is kind of averagely in the library. Take note, the ratio of number of storybooks to number of reference books to number of magazines in the library, which is 6 to 15 to 10, is not the real number of books. It is only a ratio. But what if somebody went to the library and they count and count and count? They find that, Miss Chiling, the number of magazines in the library is 100 books. So if somebody tells you this, and you know the ratio of different kinds of books, can I find number of reference books? Can I find number of storybooks in the library? Think. Try to get this 10 to 100. Is there a relationship there? 10 to 100. Yeah, I think there is something there. 10 becomes 100. It becomes bigger. So times 10 times 10 is 100. Oh, ratio to real, there is a relationship of times 10. So I can know that this number of reference can be also times 10. And I'll get the real number of books, reference books in the library, which is 150. And this too can also times 10. And from here, I can also know the number of storybooks in the real library as 60. So 60 storybooks, 60 reference books, 60 magazines in the library. And if they ask you one question, how many numbers of books in the whole library? From here you can calculate 60 plus 150 plus 100. You should be able to get the number of books in the library altogether is 310 books. So this is how amazing. If you know only this information and the ratio, you are able to know other information as well, and as well as the total number in the real library. Cool. Here is one story about donation of mask to COVID hospital. So 3 persons has donated a mask, which is Mutu, Ali and Chong. So there is a ratio of number of masks donated by Mutu to Ali to Chong, which is 2 to 6 to 5. So from this ratio, we understand that Ali donated the most, 6 is the highest number. Mutu donated the least, 2 is the smallest number. But this is only a ratio. Ratio doesn't mean the real number of masks donated by them. So it doesn't mean that Chong donated 5 masks, and Ali donated 6 masks, and Mutu donated 2 masks. No. So one more information comes in. In the real, Chong has donated 900 masks. So my question to you is, can I use this information and this ratio to find out how many masks did Ali donated and how many masks did Mutu donated? How? Think. Oh, I have one ratio here. I have also the real number donated is here. So 5 and 900. Is there a relationship between 5 and 900? Maybe I can find out. 5 to 900 becomes bigger, so times. Times what number? I do not know. Let's do this. 900 divided by 5. From calculator, you'll get 180. Try 180. Is 5 times 180 becomes 900? Yes, correct. So I can say that from the ratio to real world, there is a relationship of 180. So I can say that ratio times 180 equals to the number of masks one person has actually donated to the COVID hospital. So if this is so, I can say that 6 times 180 becomes, from calculator, you'll get 1080. So Ali has donated 1080 masks to the COVID hospital. Same like Mutu, 2 times 180. So Mutu has donated 360 masks to the COVID hospital. So amazing, isn't it? From this ratio and this one information on the real case, I can calculate the other two. Also, not to forget, I can also calculate the total mask donated by Mutu, Ali and Chong to the COVID hospital. How? Here are the numbers. So I can total them up. It's 2,340 masks. So from information, from ratio, I'm able to get this. Same story, but different question. The number of masks donated by Mutu to Ali to Chong is still in a ratio of 2 to 6 to 5. One for more information given is, in real case, the total number of masks donated by Mutu, Ali and Chong is 2340. The total of number of masks donated by Mutu, Ali and Chong is 2340. My question is, how many masks did Mutu donated and Ali donated and Chong donated individually? How to find? It says total. So can I find another total here? If I'm able to get this total, then maybe I can find the relationship. Break the chain. Maybe I can take this 2 plus 6 plus 5 and the total of this is 13. From this 13, can I find any relationship here? Yes, because the ratio and the real always has a relationship. 13 to 2340, it becomes much more bigger. So I imagine it could be times. Times what number? I do not know. Put into the calculator. I take the bigger one, divide by the smaller one. Calculator should give you 180. Check again. So 13 times 180 equals to 2340. Bingo. So I know the relationship between ratio and the real one has to times 180. It is 180 bigger. So from here, I can calculate the number of masks donated by Ali. Let's try. So for example, I can say this is X equals the total number. So this to here times 180. Number of masks donated by Ali is 6 times 180. So we should be able to get 1080 masks in real Ali donated to the COVID hospital. The same to Chong. 5 times 180. Should be able to get 900. Chong has donated 900 masks to the COVID hospital. Same thing to Mutu times 180. So I can say this is that 2 times 180 equals to 360. Motu has donated 360 masks to the COVID hospital. Hi there. Here is the up level of ratio question. Let's understand the story first. Listen carefully. So this is a wire from P to S. It is separated into 3 different parts: PQ, QR, and RS. So you can somehow sense and feel a bit. PQ is longer than QR and QR is longer than RS. So the entire length here is 12 cm. And the question gives you 2 more important information. It says RS is 2 cm. What can you interpret from here? Oh, here is 2 cm. Entire is 12 cm. So 12 minus 2, I'm able to get PR, right? So put this down first. So I know that PR is equals to PS, the entire thing, minus RS. So PS is 12 minus RS is 2. So from P to R is 10 cm. See? From this information given from the question, you're able to know that from P to R is 10 cm. Then next, look at the second information given here. It says the ratio of PQ to the ratio of QR is 3 to 2. What can we know from this information? Think a little bit. 3 to 2. So from this, very obviously we know that PQ is slightly longer than QR because 3 is more than 2. But what if I break it down here? 3 plus 2. How much will you get? I'll get 5. Why do I need to times? Oh, sorry, why do I need to plus it? I total up this 3 plus 2 becomes 5 because I know that PR here is 10 cm. So if this is 5, also this is equals to 10 cm. 5 becomes 10. It's become bigger, right? So times how much? Put into calculator, I'll be able to get 2. So this is 2. So if this one is times 2, this will be also need to times 2, and this times 2. And obviously, I'm going to change this back to ratio again. 3 times 2, there is 6 here. 2 times 2, there will be 4 here. And from here, it becomes very obvious already. So we put it back. 6 cm is PQ. PQ here is 6 cm. Put it back. QR is 4 cm. QR is 4 cm. Double check. 6 cm plus 4 cm plus 2 cm. 6 plus 4, 10, 10 plus 2, 12. Yes, 12. Correct. So come back to the question. What does question want? It wants the ratio of PQ to QR to RS. PQ to QR to RS. Do we have all the measurement? Yes, we have the length. 6 cm to 4 cm to 2 cm. Put it down together the unit. 6 cm to 4 cm to 2 cm. What is next? Can we further simplify it? Yes. Let's cancel off all the unit. We'll be left with 6 to 4 to 2. What is next then? Simplify it. Can I divide by 3? No. 2 maybe? Yes, try 2. It has to be a whole number. So you'll be able to get 3 to 2 to 1. 3 to 2 to 1. It's a ratio of PQ to QR to RS. Is this a simplified ratio? Yeah, I think yes. Because it can't be further simplified anymore. So this is a very little bit complex question because it has a few steps here you have to find in order to get the final answer. So first, understand the story is very, very important. Understand the story. It gives you this information. So from this information, you link with what is already in the here So you find 12 minus 2, I'll get here. From this is a total and it's given a second information here. Total this out, I'll be able to find out that, oh, the relationship is times 2. So times 2 times 2. Here is the exact length of here. Then only I put it all back to the question and further simplified it.